Howdy, howdy, this is Mr. Potter. In this unit, we're going to be talking about another type of structure, another data structure called the array stack. So I want to first illustrate what exactly we're talking about when I look at a stack. So a stack is probably easiest to think about if I were to think of a stack of papers. So I've got a stack of papers here. And if I'm looking at this, then what I will do is I will see the paper that's on the top. In reality, what I've got here is I've got a whole bunch of papers in a pile, but really only the top is accessible. I can look at this top, but I can't look at anything else that's down here. The only way that I can access these things down here is if I were to remove the top of this stack. And if I were to remove the top, then I would have access to the next level of this stack. And again, I could remove the top of this stack to get to the next level. And then, so in other words, I have to actually remove something before I can get to anything else in this stack. Our stack actually starts off empty. So here is my stack. But I want to add stuff to the stack. The first thing that I add will be the last thing that I'll be able to access because it's going to be buried in all of these other items. And every time I add an item, all the stuff that's below it is going to be inaccessible to me. So I have the ability to put stuff on the stack, I have the ability to take stuff off the stack, and I have the ability to peek at the stack, to see what's on it in a non-destructive manner. Keep in mind that putting something onto the stack is going to change the stack. Taking something off of the stack is going to change the stack. But just looking to see what's on top of the stack, getting that data off there, that's non-intrusive, it's non-destructive. So we're going to talk about how we're actually going to go about implementing this. So the first thing that I'm going to need is the actual structure itself. And it's probably going to be easiest if we think of this as some type of array. So I can talk about the array and its cells. And I'm going to need some place where this is going to represent the top of the stack, where everything before this is data. And then this is going to be the place where new data can be put in. And as soon as I put new data in here, my top is actually going to move over here. So in other words, whenever I put stuff onto the stack, then I'm going to move my head or my top over. And whenever I take stuff off of the stack, then now the newest place for me to put data in is going to be this spot right here, this spot here. So I'm going to need some type of data structure. So I'm probably going to need an array of type T, kind of like what we did the templating when we were talking about our array list. I'm going to need some a variable that's going to keep track of the top or the head. And different versions of different books will use top or head, but they're both referring to the same thing. It's the first accessible part of memory. I'm going to need to be able to resize an array because this is a fixed data structure. So when this thing is full, and I'm going to know that it's full when the last cell that I have is my top, then I'm going to need to change the size of it. And so I'm going to need some way to resize it. And the way that we did the doubling resize for our array list is probably going to be the best way to approach this. So I'm going to need this type of data structure. And I'm looking at this stuff to be private. Now when I'm looking at public stuff, I'm going to need some way to peek at what's at the top of my list. Now keep in mind this peek is non-destructive, meaning that I can't destroy anything. This isn't going to change my list as well. But I'm going to need some way to remove, and in Stack parlance, we actually call this pop. This is our destructive data recovery. So in other words, when I do this, I'm actually changing the list. I am getting rid of something on the list, and I am changing it so that that spot is the newest spot that stuff can be accessed. And then I'm also going to need a way to put stuff on the stack, which we call push. And of course, this is also going to be destructive. It's going to be altering because it's going to physically change this list. So this is what I'm looking for the structure of our stack. So let's go to our client. So I've got a client set up here. And what we're going to do is create a file. So I'm going to do a new file, and we're going to call this stack.h. So this is going to be our header file. And I'm going to go ahead and include IOStream, and we'll take care of using namespace standard. We'll talk about whether we need this in just a bit. And we're going to define stack h. And remember that we talked about this definition here when we were talking about this idea of a circular reference, because stack.h is going to include stack.cpp, and stack.cpp will include stack.h, but it's not actually going to include stack.h if this has already been defined, which means stack.h has already been loaded. Remember that our header file contains our prototypes, and it's also going to contain our default constructor, whereas our class file is going to be in the CPP, the actual code that we're going to write. So I'm going to set this up as a template for class T, and we're going to define our stack. So remember that when I define stop that. So when I define a stack, remember that I need to make sure that my class definition ends with a semicolon. I'm going to have two parts here. I'm going to have private data, and I'm going to have public methods. So in our private, we're going to need to have some type of array. Remember, we talk about arrays being a pointer, so this is going to be our data. And we're going to have to keep track of the top of our stack. We're also going to need to keep track of our array size. I know that we can use the built-in, the way that we talked about when we were talking about pointers, where I could take the size of the array and divide by the size of the first element. Because remember, we did talk about size of, I could do size of data divided by size of data sub 0. That would get me the same thing, but it's just going to be easier for us to keep track of the array size as a variable. Let me adjust this down so we can see stuff. And then also what we're going to need is, we talked about the resize method, which of course is going to be a mutator, so void resize. And so what this is going to do is it's going to allow us to resize. And we probably should also have a Boolean method called need to resize. That way we can tell if we actually need to resize before we go about resizing. In other words, if the top is at our array size, then we know we need to resize. So I'm going to have my public. This is going to be my default constructor, so my stack. And the idea here is that I'm going to set up my data array, and I'm just going to do it as a new array of t of size 5. And we're going to use this idea when we get to our resize method up here, that we're going to basically double it every time after we copy those elements over. I'm going to go ahead and set our size to 5, and the top is going to point at 0 because this is the first available space. So this is the size of the array that I need to keep track of. This is going to be the first available space. And so that's my constructor, and in addition we're going to have our push, which is going to change, so that's a void. So push, which is going to be t item, that's going to be added to our array. We're going to have peek and we're going to have pop. So those both are going to return an item. So peek and t pop. And then I'm going to create a bool is empty method so that I can tell if it's empty or not. I'm basically going to return if my array size and top are in the right spots. So this is all that I'm going to have for my stack. And then down here, I'm going to make sure that I include stack.cpp. So this is my stack file. I'm going to go ahead and save it, and then we're going to write the code for stack.cpp. So stack.cpp. And so now what we're going to do is we're going to check to see, hey, has this stack h variable that we declared up here, has it been defined yet? If it has been defined, that means the stack.h file has been read. But if it hasn't been defined, so if not defined, stack_h, then we want to include stack.h to make sure that that file actually gets loaded, and that's the end of our if. And because we're dealing with objects of type T, it'd be nice to make sure that null has been defined. So if not defined null, then we're going to define null to be \0, and that's going to be the end of that. So now I'm ready to talk about methods. So we've already done our default constructor, so now we need to talk about push. So I'm going to have template for class T, and we're going to have this be a void, and the class scope is stack sub T, and we're going to push an item of type T. So the first thing I need to do is I need to see if we need to resize, then we're going to resize. If we don't need to resize, we're just not going to do anything. But now I'm going to say that data sub top is going to get item. So this is going to put item in our array at that newest spot, and then I'm going to top plus plus. Now I could combine these two steps here. I could just put data sub top plus plus, and what that does is that's going to assign item to the appropriate spot and increment automatically. But I think having it like this is a little bit clearer of exactly what's going on. So this is our push. So if we need to resize, then we'll resize it. We'll put that item in our array, and then we'll go ahead and increment to the next element of our array. All right, so that's our push. So let's talk about peek. Now remember, peek and poke are both going to return a type T. So template of class T, and we're going to return a T called stack T : peek, and we're going to find out if there's anything at the top. So if the head or top is equal to 0, in other words, if the first spot that we have that's available to put something in is the 0 spot, in other words, if we're empty, then what I want to do is I actually want to return null. Because null is basically we're saying there's no object in the list. And then otherwise I want to return data sub top -1. Remember that I'm going to return whatever's in the previous spot, and that's a problem if top is 0. If top is 0, then there's nothing in the list. If top is anything but 0, that means that 0 is not the first place to put something, which means there must be something in position 0. So putting top -1 and referring to that cell in the array is not going to be an issue. So that's our peek. Our pop is going to look a lot like this. So template class T, so we're going to have T stack template T pop. The only thing that's going to be different here is that I'm going to need to make sure that I also decrement my top, because I need to make sure that that space is now available to put something. So again, if top is equal to 0, then we're going to return null. Otherwise, we're going to first decrement, so we're going to say top -, and then we're going to return data sub top. So notice that what we're doing here is we're referring to that position, but we're also making sure that we're setting it so that that position is now the first place that new data will be added should we push later. So this is our push, our peek, and our pop. So this is the ones that actually allow us to interact with the stack. So now I should deal with my isEmpty method. So template class T, and T stack template T : isEmpty. And I want to know if it's empty, basically is top equal to 0. So I want to return the result of that Boolean expression, is top equal to 0. So that takes care of isEmpty for me. So these are all of my public methods. So now I need to deal with the private methods. And the private methods primarily deal with resizing this and seeing if I need to resize it. So we're going to start template class T, and we're going to have this be a bool, stack template T, and this is going to be need to resize. So when do I need to resize? I need to resize if the position that I have to put something in, say top, is equal to the size of my array. Because if my array holds 5 items, and I'm saying 5 is the next position something's going to be added to, then I'm going to have a problem if I try and put something in box 5 of my array. I'm going to need to make sure that I resize so that my array then goes from 0 to 9 instead of from 0 to 4. So what I want to do is I want to return the result of this Boolean expression. So if the top is the same as the array size, then I've run out of space in my array and I need to resize here. So now the question is, how do I actually go about resizing? And that's the tricky part. So what I really need to do is set that up. So template class T, and this is going to be a void stack template T resize. And first thing I'm going to do is set up a new pointer array. So T pointer new data gets new T, and we said that the idea is that we're going to double the size of the array. And I'm going to need to make sure that at the end, I make sure that I double that array size, because this is now my new array size. And then what I also need to do is copy the data over element by element. So for int I gets 0, I is less than r size, I plus plus, and just copy the data over. So new data sub I is going to get, new data sub I is going to get data sub I. So just copying the data over element by element. And then now that I've done that, I have this new data array, which contains all the data that data array held, but is twice as long. So it now has spots for stuff to be added to. So I'm ready to say, let's let data get new data. In other words, this is now my new data array. And now if this is my new data array, it's twice as big. So our size is going to get multiplied by 2. And that's pretty much it. I mean, we've taken care of all the things we talked about in stack.h. Let's save this. So I have my data, my top and my array size. These are my instance variables. And then I also have a resize method, which we just did, and a need to resize method. That's all my private stuff. For public, we have our constructor, and then we had 4 functions that we wrote. We wrote a push function, we wrote a peek function, pop, push, and is empty. So we are good on that. So the last thing I want to do is I want to write a real quick file just to test this, just to see if it works. So we're going to call this stack tester.cpp. Let's try stack tester.cpp. Let's rename this. That would be nice. Okay. So this is stack tester.cpp. And all we're going to do is just real quickly just write a real quick program. It's just going to add some elements to the stack, see if all of the methods that we wrote that are public work. So we're going to include stack.h. We're going to include IOStream. We're going to using namespace standard. And then we're going to have our int main. So the idea behind this is that I want to create a stack. So I'm going to have a stack of type integer, which I'm going to call s. And the first thing I'm going to do is I'm going to see, is s empty? So I should try and see out the result of that. I should get a 0 or 1 because it is in fact empty at this point. Then what I need to do is I need to push stuff into it. So for int I gets 0, I is less than 5, I plus plus, and I want to make sure that I'm adding stuff that's pretty different. So I'm going to say s.push, and I'm going to do I times I plus I. So in other words, the first time I'm going to have 0, the second time I'm going to have 1 plus 1, which is 2, the next time I'm going to have 4 plus 2, which is 6, the next time I'll have 9 plus 3, which is 12, and so forth. And so when I see out the result of s.peek, then I should see what's on top, which is going to be where I is 4, and 4 times 4 plus 4 is going to give me 20. So I should have a 20 on top. And then what I want to do is pop as much as I can. So while not is empty, then I want to see out s.pop along with a space, and then fix my fence post here. So just something real basic like that. So I'm going to save this, and we're going to compile this. We haven't compiled it all in this episode, so hopefully I don't have any egregious errors. So with output of stack tester.exe, and just a few issues here. So let's see. That says expected semicolon before the closed bracket, and this is in stack peak. So if I go to stack peak in stack.h line 30, stack.h, stack tester, so this would be in our peak. Did I just forget a semicolon? Yeah, I just forgot a semicolon here. That's wonderful. And then it says prototype for this does not match any in stack class. So let's see, it's saying I don't have an isEmpty method. Bool is empty, and over here my isEmpty should have been of type bool. Yeah, that's makes sense. So let's go ahead and compile this again, see if that works. And what I'm running into, okay, I've got this while isEmpty. IsEmpty is not declared in the scope, so I need to ask stack if it's empty. So I need s.isEmpty. And I think that should be it. Which you'll notice that the only thing that I have left are warnings about null, because null is an integer type and we're actually returning a type t. Ordinarily, I'd change this so that I'm dealing with pointers, so that returning null returns a null memory address. But for now, I just want to deal with integers, just make sure this is working. So if I run this, so /stack tester.exe, then notice that the first thing I do is I ask, is it empty? And it is empty. I get a 1 for that Boolean expression. The next thing I do is I push all those elements on, and the last element pushed is where I is 4. So when I peak, I get 4 times 4 plus 4, which is 20. And then I pop, and keep in mind that it's going to give me the values in reverse order. So the first thing that pops off is the 20. The next thing in the stack is 3 times 3 plus 3, 2 times 2 plus 2, 1 times 1 plus 1, and 0 times 0 plus 0. So the stack seems to work. So what we're going to do next time is we're going to talk about some of the applications of this stack so we can see how this is actually used in the real world. So once again, this is Mr. Potter. Thank you for watching. Have a great day.